Good morning from Nuremberg in Germany, and a very warm welcome to the webinar Digital Twin. A buzzword becomes reality. My name is Matthias Beetz, and I'm your webinar guide. Your speaker is Stefan Hecht. He will present the webinar and answer your questions afterwards. In today's webinar, we will speak about which simulation types are available and the most important differences, how to find the right software provider, how ProSimulation helps in your engineering process, and how we have optimized drive systems with ProSimulation. During the webinar, you are muted, but you can ask us questions at any time using the chat function. You can find the chat button right down in the corner. After a 15-minute presentation, we will answer your questions. We will record the webinar and you will receive the link to the recording via email. At first, some words to the company of Baumiller. Baumiller is a global family-owned company with more than 90 years of experience in its core business of drive and automation systems. And now, Stefan Hecht will start with his presentation. Stefan is an expert in the simulation and dimensioning of drive systems in industrial automation. Enjoy the webinar.
Thank you, Matthias, for your introducing words. I would like also to warmly welcome you to this webinar. First of all, I would like to introduce you to the agenda for today's presentation. The word digital twin is in everybody's mind, but what does it mean and what can be represented as a digital twin? I will answer this in chapter Digital Twin Simulation Types. Have you already heard of our simulation tool, ProSimulation? No? Then I would like to give you a brief overview of the advantages of our product. Have you ever considered what market requirements you are currently facing and what possibilities the simulation offers? I would like to briefly report on this in section Current Market Requirements. Is it possible to improve your engineering process? Yes, ProSimulation offers you a possibility. You can find out how to do this in the chapter How ProSimulation can help you in the engineering process. In summary, I will give you an outlook on the possibilities of simulation at Baumiller. We will conclude the webinar with a question and answer session. What do you imagine with the word digital twin? The most common thought is the virtual image of an entire production plant as shown here in the picture. Individual parts of the entire machine can be also viewed as a digital twin. For example, a machine part of this production plant. Since there are different physical areas for these individual parts and different goals are proposed with the digital twin, there is a wide range of simulation types, which I will now briefly introduce. First, process simulation. Process simulation is used to simulate an entire production line as shown here in the picture. It optimizes the processes and improves the plant productivity. With the circuit simulation, electronic circuit can be tested for its function and fail functions. The real-time or HIL hardware in the loop simulation makes it possible to create a digital twin of a system. For example, this production plant in the picture. Then you are able to connect this digital twin to a real existing PLC. This enables the user to create a program code before commissioning and to find and correct any errors in its code. The FEM simulation is used to test the mechanical strength of components. It is simulated whether the components can absorb the resulting forces without being deformed or destroyed. How liquids, for example water or oil, move in pipes or valves can be determined with the flow simulation. Let us now come to the type of simulation we are dealing with today, the simulation of drive systems. It consists of drives, motors, and its mechanics and infeeds. A well-known tool is MATLAB and Simulink, but we have developed our own tool specially tailored to the drive components from Baumüller to carry out this drive simulation. This tool is called ProSimulation. What is ProSimulation and what advantages does it offer for you as a customer? ProSimulation is a simulation tool for sizing, optimizing, and commissioning of drive components. The tool enables you to size drive and automation system, do virtual commissioning, fault analysis, and to optimization of machines and applications. It also enables you to set and optimize drives and applications without the risk of damaging your components. ProSimulation allows you an easy start into your own simulation, because there are already finished models of our drive components and some mechanical models are available. In addition, modeling and operating is very easy. I will show you that with an example later. Today, the mechanical engineering have to deal with many challenges. To reduce the time to market, shorter innovation cycles of new products, and how to remain competitive. This means how to develop products demanded by the market. On the other side, we have challenges like strong cost pressure, economic difficulties like current COVID-19 crisis, and limited manpower in your company. The main challenge is to get these problems in balance or improve the left side in your favor. One possibility, this is offered by the digital twin and the simulation with ProSimulation. Therefore, ProSimulation enables you to improve the time to market of your product, to shorten the innovation cycles, and at the same time to remain competitive without increasing costs on the right side. I will show you how this is possible by using the engineering process. First, I will explain the conventional process of sequential engineering of a spindle axis of a CNC table to you. Here, all steps are carried out one after the other. The first is the mechanical construction of the spindle. Then, the electronic technician selects the appropriate motor for this application. An optimized motion profile with minimum power losses is then sought out. And finally, the drivetrain in the entire machine is put into operation. With ProSimulation, it is now possible to parallelize these steps through the simulation. This is called simultaneously engineering. As an example, the search for a suitable motor can already be started in the simulation during the mechanical design. The same applies to the other steps. These can be processed simultaneously through simulation. This saves time and money, and above all improves the time to market for your product. How ProSimulation can help you in the individual steps, I will explain using suitable applications that we already have carried out with ProSimulation. The first step, the mechanical construction. I will explain this example using a cutter application you can see in the left picture. This application is a highly dynamic cutting unit that cuts cigarettes to length in a packing machine. In this case, the customer wanted to build a new machine that, due to market requirements, should have higher productivity and improvement in dynamics. With ProSimulation, we support the customer in his mechanical construction by showing available components and being able to determine the resulting minimum cycle times. Furthermore, the control behavior of the current mechanics could be estimated with ProSimulation. These resulted in the following advantages for the customer. We were able to assess the feasibility of his mechanical construction with our components at an early stage. We minimized the risk of undesirable developments and increased the interdisciplinarity between the mechanical construction and the electrical engineers. Also, we represented an estimate between increased productivity and the associated higher costs of the mechanical and drive systems. I will show you the drive sizing using the dual pot application for pick and place task. With this dual pot, pieces were picked from a belt and put to another belt, for example. It is a high flexibility of the dual pot with regard to possible loads, and the executor movements is important for the customer. Here we are able to use ProSimulation to show the control behavior with different loads and movement profiles of motor drive combinations, as well as optimally setting the drive and the required properties and thus dimensioning the drives as efficiently as possible. For the customer, the following advantages resulted from the use of ProSimulation. Efficient drive sizing. The motor could be dimensionated as small as possible, but as large as necessary. As a result, the entire footprint of the dual pot could be reduced. Furthermore, it was demonstrated how flexible the dual pot can be used by demonstrating the bandwidth of the possible loads with simulation. This could also be used by the customer as a sales argument to his customer. The third engineering section is the motion profile. The aim of this engineering step is to find an optimal motion profile for the machine that has the lowest motor losses and is the most gentle to the mechanics. The advantages are developed with the servo press application. The customer required a high productivity with simultaneously engineering efficiency. By using ProSimulation, the customer was able to recognize the power peaks of his machine through energy management and to reduce them through suitable actions. Furthermore, he was able to find an energy-efficient motion profile by trying different settings. The following advantages resulted for the customer. He was able to save energy while increasing profitability at the same time. The grid costs could be lowered by reducing the grid connection power. An optimal motion profile with reduced jerks extended the maintenance cycles and at the same time increases the availability of the machine. The last step, the commissioning, I will explain on a glue roll application. Glue is applied to the paper with a roller. The structure of the mechanics you can see in the right picture. A motor is connected via a gearbox to a roll. The difficulties lies in the high load inertia ratio of 1 to 280, which is difficult to control. Oscillation occurred during the commissioning, and the clutch and the gearbox were destroyed. As you can see in the picture, the speed behavior. The speed value in blue and the current in green. The black graph represented the speed from the speed set from the customer. As you can see, we have an oscillation in the speed value. Therefore, the clutch and the gearbox was destroyed. The on-site employee asked us if we could help him to improve this problem. Therefore, when we carried out a virtual commissioning with ProSimulation at our workplace. To do this, we first created the simulation model in ProSimulation. This is shown in the picture. It consists of the customer specification, in this case, the speed set value, the drive and the motor model from our components, and the customer's mechanics, in this case, the inertia and stiffness from the roll. I will show you how easy ProSimulation can be operated and how it can be set to our drives with a short demonstration of this virtual commissioning. In this case, we open our ProDrive engineering tool, then select the drive who was set on the plant. Then we are able to load the parameter sets from the plant. This was sent from our engineer on the plant to us. We load this data set in ProDrive and then open our ProSimulation engineering tool. Here we are also able to load the simulation project we are already established. This consists of the 3 models I explained in the PowerPoint presentation. With ProSimulation, we are able to load oscilloscope measurements as reference to our simulation. So we are able to compare the real measurement and the results from our simulation. As you see, there are the real measurements from the plant. In this case, we only want to see the speed values. Then we simulate the simulation project with the data set from the plant. As you can see in the graph, the simulation results of the speed actual value have the same oscillation as on the plant. Therefore, we can choose the simulation operates exactly the same as the real application. Then we can do the virtual commissioning. In this case, it was necessary to adjust the speed controller settings. We adjusted them to the right factors. We are also changed the feed forward factors to the default values because this was set to another value from the application engineer on the plant. Now we're able to simulate the whole system with the new data sets. So we can use the graphical interface to parameterize our simulation. And as you can see, now the graph have no oscillation. They are smooth and continue to follow the speed set value. As same as the current, there are also no oscillations in the graph. So now we are able to export these data sets with the perfect parameter sets as a data set. This could then send to our customer on the plant, who are uploaded to the drive, and the complete application runs properly. Therefore, we have to save it as a file and send it to them. The virtual commissioning resulted in the following customer benefits. reduced commissioning time, as it is possible to quickly find the right settings without damaging something further at our workplace, as well as finding the optimal setting for the process. Therefore, you can see in the left picture the speed behavior before virtual commissioning. We have an oscillation in the current and in the speed value. And after we adjust the right settings in the virtual commissioning, you can see the speed behavior in the right picture. We have a smooth graph without any oscillation. The findings of this application are: with ProSimulation, we can also improve and optimize existing machines. We can support the service by simulating the problem and identify possible solutions. The most important thing, however, is the realization that simulation should already be integrated during the conception phase of a new machine. In this case, the engineering step, mechanical construction. In order to identify such problems at an early stage, to point them out to the customer, and to identify possible solutions. In the outlook, I would like to briefly discuss the Baumüller lifecycle management for products. It consists of 5 sections. With our tool, ProSimulation, we can offer the first 2 areas. Important points here are securing the feasibility of your machine, as well as the virtual commissioning with a corresponding shorter commissioning time and a reduction of time to market for your product. We also offer virtual machine commissioning with real-time simulation that reduces also the time to market and improves software quality. Real-time behavior and control technology results in construction of a digital twin of your entire system. At last, condition monitoring with predictive maintenance are also able with Baumüller. I would like to thank you for your attention, and I will hand back now to Matthias.
So I'm back. Thank you so much, Stefan. It was a very interesting presentation. I'm looking to the chat and I can see some questions. The first question is, how much time is saved by the simulation? And how do I know that the simulation is profitable?
How much time is saved demands on the step you're joining with the simulation. When you use the simulation in the first engineering step, in this case, the mechanical construction, you can save about 30 to 40% of time for your product.
Okay, and what data is needed for the simulation?
As data we need from the customer, we need the motion profile, in this case, for example, the speed set values or position set values, then the structure of the mechanic of the application, for example, also data as inertia, in this case, for example, the inertia of the roll, stiffness of the connection from the motor to the application. And then also the size of our drives and motors.
The next question is, how long does it take to build the simulation?
To build up a simulation is very quick. As you can see, as you have seen in the movie or in the pictures from our build-up simulation for the virtual commissioning, we only have 3 blocks. So you can put and insert them in our simulation tool, and then you just have to set the data set, and I think half an hour up to an hour you can build up a simulation that runs properly.
Okay, you spoke about hardware in the loop. What does it mean in detail?
Hardware in a loop or real-time simulation is that you build up a digital twin, for example, from the production line. Then you can connect it to your real PLC. This enables the customer or the user of this program to program the PLC code, test it for faults, and improve the code.
Okay, and the next question is, why should I use ProSimulation instead of MATLAB Simulink, for example?
ProSimulation is suitable for our drives and motors, so you don't have to have special needs in simulation know-how. So you can just insert the blocks in the ProDrive and ProSimulation, and then you are able to parallelize these simulations with the virtual commissioning. With MATLAB Simulink, you need much more knowledge for simulation and how to build up simulations properly.
The next question we have is it possible to integrate ProSimulation to other real-time simulation software like ESG, Virtuos, or industrial physics?
In this case, we are not able to implement them in other cases because we operate in ProDrive, our engineering tool for our drives and motors. So this is just in ProDrive. We cannot include it to other engineering tools.
The next question is, could you please describe the production, the solution, which Baumüller delivers here? Do you sell a software license or ongoing services?
We service both types. On the one hand, you can use the simulation on your own. Then you have to buy a license for your PC, or you can ask us to build up simulations, and we offer the service for you.
Okay, at the moment we have no further questions. Please use the time you can ask us. Otherwise, if you have further questions after the webinar, you can send us your questions via mail to the mail address marketing@baumüller.com, and we will answer your questions afterwards. Okay, thank you so much for participating at this webinar. We have additional information about our webinar on our website under Baumüller Insights, and you can find an information about an additional webinar. We would be happy to see you again at this webinar, maybe. Thank you so much for participating, for your attention. And in this crazy time, it's important to stay safe. We say goodbye and all the best for you. Oh, I'm looking back. Okay, no further questions. Okay, we say goodbye and stay safe. Bye-bye.